telescopes allow us to view farther than ever before. The most potent one to date is the recently launched James Webb. However, that won't last for very long. Today on the Space Report, we're diving further into the reasons why NASA's upcoming telescope will be even more effective than the James Webb. Do you require answers to the important questions? Are you an eager independent thinker? Make sure to subscribe to the Space Report and ring the bell to stay up to date with more inspiring videos like this one. The German-Dutch spectacle manufacturer Hans Lippershey is credited with creating the earliest known telescope design, which he attempted to copyright in 1608. A year later, Galileo Galilei, a renowned astronomer and mathematician, adapted this blueprint to create his own instrument. Galileo used a refracting telescope, which collects light through a lens to create a picture. Since then, a great deal of people have improved the telescope's capabilities. Using a smooth, curved mirror rather than a lens to gather light, Sir Isaac Newton created the first reflecting telescope in the 17th century. Particularly, Newton's version has grown to be accepted in astronomical research. To boost power and look farther into space, we have developed bigger and bigger telescopes in the modern era, but this strategy has its limitations. The deployment of telescopes in actual space, where they would be free from atmospheric influence, was the next crucial step. Up until recently, the Hubble Space Telescope, which was launched in 1990, was by far the most well-known. It has produced some amazing photographs throughout the years, enabling us to look further and further into the cosmos. Although Hubble is still in use, its far more potent replacement, the James Webb Space Telescope, was put into orbit in December 2021. The 6.5-meter diameter primary mirror on the Webb Space Telescope, the largest and most powerful space telescope ever constructed, is gold-plated. Its spectrographs and cameras enable it to see the universe at frequencies lower than those of Hubble, while the gold plating on the mirror provides infrared reflectivity. Webb can capture images of more than 100 items at once thanks to a micro-shutter technology. While the telescope also has a tennis court-sized sunshield to keep everything cool enough for the machinery to work correctly. Due to their size, the mirror and sunshield had to be folded before launch and were only unfurled after reaching orbit, a difficult process that took days. With Webb now fully operating, astronomers may view the most vivid views of the cosmos. Future telescopes, meanwhile, are already being developed to do what Webb is now unable to. The Nancy Grace Roman Space Telescope, named for NASA's first female executive and mother of Hubble, is arguably the most eagerly anticipated next telescope of them all. It is currently being built, with a launch date of sometime in 2027, and was formerly known simply as the Wide Field Infrared Survey Telescope. The Roman will differ from Webb in some ways even though they are similar in others. Roman will have a wider field of view than Webb, allowing it to acquire large, sweeping photographs of the cosmos, though at the expense of some resolution. Webb captures high-definition photos in a very narrow range. As a result, the Roman will be able to take considerably broader pictures of the universe and will be better able to investigate some of the most puzzling astronomical questions, such as the characteristics of dark matter and dark energy. And a win here would represent one of the most important recent scientific findings. Roman will also have a coronagraphic instrument that will allow it to directly image and describe exoplanets. This might then set up future observatories to capture even more detailed pictures of Earth-like exoplanets in other star systems, which is a crucial step in the search for more places that might potentially support life. Similar goals guided the building of the Hubble Space Telescope, whose images unquestionably revolutionized astronomy. Actually, they'll keep doing it. Hubble won't be obsolete even when Webb and, in time, Roman are in the sky. The only telescope created to capture photos in the ultraviolet spectrum will still be it. Thus, it will continue to catalogue the universe with all other observatories. But once more, the Roman will outshine it in terms of cosmic vision. It may be able to take pictures up to 300 times larger than those Hubble and Webb can, and many times wider. This would allow astronomers to see entire galactic ecosystems. For comparison, Roman is expected to have covered an area of the sky that is around 50 times wider after only 5 years of operation than the Hubble has throughout its entire 30-year existence. In contrast, the Webb, which is designed for narrow imaging, is unable to compete with Roman in this supermapping challenge. In just 5 years, NASA will usher in a new age of space exploration with the launch of Roman. It will provide gleaming images of the cosmos that will enable astronomers to learn more about hundreds, millions, and possibly billions of stars. Roman will research the fundamental environmental elements that cause stars to differ from one another, and will reveal every detail of the universe's jigsaw puzzle. What's really amazing, though, is what the three Hubble, Webb, and Roman could be able to accomplish together. Together, these telescopes will examine a never-ending stream of objects from 3 distinct angles and a wide range of wavelengths. There will be more of the universe to appreciate than ever before for the scientists, space agencies, and organizations that get to examine their data. In the end, Webb is still slated to be the biggest and most potent space telescope ever built. Roman, however, has a different perspective and will undoubtedly record the broadest angles. While Hubble, the seasoned standard-bearer for all things modern astronomy, will provide as a link between the two. What will happen after that? It's challenging to say. However, even short-term technological advancements have the potential to surpass Webb and Roman in the near future. Over the next few decades, it's possible that methodological developments and fresh applications of technology will give rise to whole new approaches to cosmological imaging. For instance, creating a solar gravitational lens has been suggested as a way to increase a telescope's field of view. The gravitational lensing that the sun's gravity has on light passing through it has led Stanford astronomers Alexander Majorowicz and Bruce McIntosh to suggest a new type of telescope that will be able to examine objects behind the sun in incredibly fine detail. We might even be able to observe astronomical objects up to 1,000 times more clearly with this method than we can now. However, this technology is still a ways off because it depends on us first developing more efficient means of space travel in order to place a telescope in that location. However, there is also the Giant Magellan Telescope, or GMT, whose construction has already begun, to take into account. According to reports, this Chilean observatory, which might be in use by 2029, will have 4 times the resolution of Webb, be the largest telescope on Earth, and be up to 200 times more powerful than any other Earth observatory to date. Along with other things, the GMT will continue to search for exoplanets, but scientists are most enthusiastic about its potential precision. If it performs as expected, it will be able to distinguish finer details from fainter light sources than Webb or Roman can at this time. According to some, astronomy and telescope technology are about to enter a new golden era, making more of the cosmos visible than ever before. Numerous new discoveries are anticipated to be produced soon, and our comprehension, as a species, will quickly advance. But what do you think? How did you discover Webb's initial photo releases? What do you anticipate for Roman's future? And in 10, 50, or 100 years, where do you see this field of research going? The following step on this path will be the start of an interesting journey. And for this reason, NASA's upcoming telescope will be even more effective than the James Webb. How do you feel? Do you think we missed anything? Please share your thoughts in the comments, and subscribe to receive notifications of our newest posts. Thank you for watching.